everyone, welcome to my channel. Get ready to crack sums like a pro with simple tricks and understanding teachings. Now we are going to dive into the knapsack problem using branch and bound technique. Have you ever wondered how to pack the most items without exceeding the limit in a knapsack? We will break it down step by step using smart technique of our knapsack problem. Question for knapsack problem is: apply the knapsack problem to determine the best combination of the items in the knapsack of capacity 10 kg. Items, weight and values are given in the question itself. For A item 5 and 100, for B item 7 and 150, C 2 and 50, D 10 and 200, E 4 and 75. First we have to find the V by W value. The finded values are 100 by 5 is 20, 150 by 7 is 20.4, we are approximately taking 21, then 50 by 2 is 25, 200 by 10 is 20, then 75 by 4 is 18.8, we are approximately taking it as 19. Then the formula for upper bound is V plus capital W minus small w, Vi plus 1 and Wi plus 1. Then the values are taken for each items from this table. Then the capital W value is 10 kilogram. Then the values are taken from this table. Then V by W values are found here. We are going to find state space tree for this knapsack problem. Initially we are taking root node as node 0. Then our initial condition is V value and W value, we are taking it as 0. It is a procedure for knapsack problem. Then we are taking I value as 0. We are going to substitute the values in this formula. V value is 0, capital W value is 10 and small w value is 0. Now V I plus 1 and W I plus 1. I already told I value is 0. It is V1 and W1 value. So we are taking 20 as V1 and W1 and for the item A1. So we are taking 20 here. Vi plus 1 and Wi plus 1 value is 20. Then the final answer is 200. Upper bound value for node 0 is 200. Then we are going to substitute in this formula state space tree. V is equal to 0 and W is equal to 0. Upper bound value is 200. Now we are going to find node 1 value. Then upper bound value is equal to, we are taking V value is equal to 100 for item 1. Then W value is equal to 5 for this I1 value. So we are taking item 1 here. The weight is 5 and the value is 100. So we are taking this. Then V value is 100. We are substituting in the formula. Then capital W is 10. Small w is 5. Then now we are moving to the V1 and Vi plus 1 and Wi plus 1 value. I is equal to 1 here. For the second level we are choosing I is equal to 1. So it will become V2 by W2. For item 2 we will have 21.4. So we will approximately taking 21 here. By adding and multiplying this value we will get 205. It is the upper bound value for node 1. Then we are going to substitute in this state space tree. V is equal to 100, W is equal to 5. Then I am going to substitute upper bound is equal to 205. Then let's go with node 2. Upper bound is equals to, then what is the value of V and W here is, we are taking V value as 0 and W value as 0. Why here is, we are taking this tree with 1 and without 1. We are assuming the item without 1, that is there is no item in the knapsack. So the value of V is 0 and W is also 0. Now we are substituting value of V and W without the item, first item A. So we are taking the V is equal to 0 and capital W as 10 and small w as 0. Then vi plus 1 and wi plus 1. Here I is equal to 1. So v1, v2 and w2, for item 2 we have v by w as 21. So substituting 21 here. So the final value is 210. It is the upper bound value of node 2. Substituting the upper bound value of node 2, 210. Now taking item 2 and item 1 is eliminated here. Now we are taking the item 2, that is B. So the value of V and W are taken from the table. Item 2, the value is 7 and weight is 7 and the value is 150, which are taken from the table. Then substitute it in the formula. Upper bound is equal to 150 plus capital W is 10, then small w is 7, then plus vi plus 1, wi plus 1. Here I value is 2. So we are taking I value as 2, then it will become v3 and w3. Then we are going to take the item 3 value of v by w value. So we are taking 25 here. So 25, which is the value is, upper bound value is 225. The final value of node 3 is 225. We are substituting it here. What is the v value? 150 and w value is 7, and I am substituting upper bound value as 225. Then without 2, we are eliminating the item 2 and 1 also. Now the knapsack is empty. We are eliminating A and as well as B, so the knapsack is empty. So the value of V is equal to 0 and W is equal to 0 here. Now upper bound value is equal to, substitute the value of node 4 here. Then we are substituting V is equal to 0, W is capital W is 10 and small w is 0, and here I is equal to 2 as I said. So V3 and W3, take the value of V by W of item 3. So we are taking 25 here. Then our final upper bound value here is 250. So our upper bound for node 4 is 250. Now moving on to node 5, with item 3 and without 3 we are going to find. Now we are going to find with 3. How we are dividing this tree is, we are taking a upper bound. So the greatest value are taken here up to 205 and 210. The greatest value is 210. So we are dividing this tree according to 210. Then here we are taking 250 because the upper bound value is 250, which is greater than the 225. So we are choosing 250 here. Then we are dividing the tree according to it. So with the 3, we are including item 3 and without 2. So the item, now the knapsack is also empty. We are including C here. So the value of V is 50 and W is 2, taking from the table here. So we are eliminating both the items A and B, so and we are taking C into the knapsack. So the upper bound value is 50 plus capital W is 10 and small w is 2. Then we are taking I is equal to 3. We are going to the third level. So I is equal to 3. So we are substituting I is equal to 3 in this formula. So it will become V4 by W4. Then take the V by W value from the item 4. So we are substituting 20 here. The upper bound value for node 5 is 210. Then substitute the value in the node 5. What is the value of V? We found out that's 50, then W is equal to 2, then the upper bound value is 210. Okay, then without 3. Now the knapsack is empty. We are adding no items. A, B, C are eliminated. So we are getting what the value of V and W? V is equal to 0 and W is equal to 0. Substitute it in node 6. V is equal to 0, W is equal to 0, I is equal to 3. It is level 3, so we are substituting I is equal to 3. So upper bound value is 0 plus 10 minus 0. Then we will take what we have to take. We have to take the V by value of item 4. That is, it is 20. So we are taking 20 here. The final upper bound value for node 6 is 200. Now I am going to substitute here. Upper bound is equal to 200. Now we are moving to node 7 with item 4 and without item 4. Then we just calculate the upper bound of both 210 and 200, which is greater 210. So we are adding our knapsack with item C and we are eliminated A and B here. So a knapsack is now filled with item C. So we are add the value of item C with the item 4. We have eliminated A and B, so we don't want to add the value of A and B here. We have added knapsack in item C. So add the value of item C with the table with the value of item 4. So moving on to the table, the value of item C is 50 and 2. We have added this one in the knapsack. So we are choosing the item 4 here. So add the value of both 200 plus 250. Sorry, 200 plus 50. We have 250 here. Then add 10 and 12. 10 and 2 we have 12 here. So now the total capacity of knapsack is 10. So we are having as weight as 12. So it is not feasible. We don't want to find this value. Then I am moving on to node 4. Node 8 and without 4. So we are eliminating option D, item D here. So what is the value of V? We have added item C. So we have to continue the value of C here. So V is equal to 50 and W is equal to 2. Node 7 is not feasible, as I already told. Then we are moving to the node 8. Node 8 value, we have find out V is equal to V is equal to 50, W is equal to 2. Then substitute the values in the formula. 50 plus 10 minus 2. Then what is the value of I here? We are moving on to the level 5, so I value is 4. So we are taking the item of V by W, that is V5 by W5. So moving on to the item 5, V by W value. So we have 19. So substitute in the node 8 V5 by W5 value. So node 8 value is node 8 value is 202. Substitute it in the without 4 value, 202. As we have not feasible in this one, so we have to choose this one also. So this one itself. So I am choosing without 4. What does it mean? I am eliminating A, B, D here. So the knapsack still have item C within it. So we have with 3 and without 4. Then I am including item 5 in the knapsack. Then what will become? C, item 5 is E. I am eliminating A, B, D here. So E and C are added in the knapsack. So add the value of E and C and of the in the table. So what is the value of C here? 50. Then we have 75. Add these two values. So the V value is 125. That is 50 plus 75. 125. Then W value is 6. 4 plus 2 is we have 6. So we would calculate this for the node 9. So node 9 value, B is 125 as I already told, and W is equal to 6. What we are doing? We are adding the value of item C and E. So upper bound value substituted in the formula. 125 plus capital W is 10, small w is 6. Then what is the value of I here? I is 5. We don't have the value for item 6. We still have the item value for V5 and W5, but we don't have V6 and W6 value. Then we would have to substitute it as 0. So upper bound value for here is 125. Substitute it in the table. Upper bound is equal to 125. Then calculate without 5. Without 5 we would have item as V is equal to the item only C would have in the knapsack without E. We are eliminating E here. So the value of V and W is repeated here also. V is equal to 50, W is equal to 2. Then the upper bound value we have to find. So as I told, V is equal to 50, W is equal to 2. We don't have V6 and W6 value. So upper bound is equal to 50 plus 10 minus 2 and 0. Because we don't have V6 and W6 value. So I am putting it as 0. So upper bound is equal to, the calculated upper bound value is 50. So we have to add 50 in the state space tree. Then what we have to do is we have to add item E in the knapsack. So the items are added in the knapsack are E and C, and we have eliminated items are A, B, D. Okay, knapsack items, these are knapsack items, and these are eliminated items. Thank you for watching our video. Subscribe, share and like our video. Thank you.